Okay, let's look at this practice question that has to do with molecular geometries and shapes. And so what I'm going to try to do is figure out why the water molecule is bent, whereas something like BeH2, beryllium hydride, is linear. So to do this, it would help if I drew the Lewis structures for each of these. So let me go to the periodic table and see the number of valence electrons for each of these elements. Okay, so here's my periodic table. Hydrogen is right here, has 1 valence electron. Beryllium is right here, has 2 valence electrons. Oxygen is right here, has 6 valence electrons. So if I look at water, right, H2O, I have 1 valence electron from the hydrogen times 2, plus 6 valence electrons from the oxygen, adds up to 8. So now I'm going to put oxygen in the middle, connect it to the hydrogen with single bonds like that. That means I used up 2 times 2 is 4 electrons. So I still have 4 left over. And the 4 that remain get delivered to the central oxygen as a lone pair. But just to compare this to beryllium hydride, BeH2, I still have 2 electrons from each of the hydrogens, or 1 electron from each of the hydrogens. But now I only have 2 electrons coming from the beryllium, so that gives me a total of 4. So now when I draw the Lewis structure, I have a Be in the middle, hydrogen there, hydrogen there. Those 2 bonds used up my 4 electrons. I don't have any left over. So now here's where the different shapes come in. Okay, if I look at the structure for water, it has these extra lone pairs in it that the structure for beryllium hydride did not. And that makes all the difference. Because if I look at H2O, I have a total of 4 electron groups. 2 bonded pairs and 2 non-bonded pairs, which means that it's going to be in the tetrahedral family, but actually going to be a bent geometry, so that the angles between the atoms are going to be approximately 105 degrees. In contrast, if I look at beryllium hydride, there's only 2 things, or 2 electron groups, surrounding the beryllium atom, which means this is going to be a linear geometry. So the angle between the H, the Be, and the H will be closer to 180 degrees. So that's why they have different shapes, depending on the number of lone pairs or pairs of electrons that are surrounding the central atom.